Greetings from the very first rocket headed to Mars. Don't worry, I'll be back for Monday class. So this is the sort of second variation on the puzzle problem in the free response from exam number 1. And you can read it there, despite my handwriting. Using switches, wire, 3 identical light bulbs, and a single battery, make a circuit with the following specifications. So number 1, when you close the switch, 3 bulbs are lit. When it's open, 3 bulbs are dark. And the bulbs have to be equal brightness, and the bulbs have to be connected to maximize brightness. So one solution to this, okay, we want a switch that will interrupt the total current in the circuit, right? So we could put a switch here, just a 2-way or SPST, single pole, single throw switch. And then, let's see, I'm going to do this, and you'll see why in just a moment. I'm going to put all 3 light bulbs in parallel, like that. Now, I think you'll agree that they are all lit when that switch is closed. And if we were to open it, well, then there's no completed circuits that involve the battery in that entire circuit. So all 3 light bulbs would not receive current. Now, that checks off a couple of our criteria here. Bulbs are of equal brightness. Well, with the switch closed, that means that they are all in parallel. So this side of them is all the same voltage value. And let me pick a different blue here. Like that. And this side of them is all in parallel as well. Or sorry, at the same voltage value as well. Okay. And so across any one of those light bulbs, you're going from red to blue. And that voltage difference is going to be whatever the voltage difference of the battery is. Okay. So that means that all 3 are at the same brightness. And because they're all getting the same voltage difference, and they're all identical light bulbs, so they're all the same resistance. And bulbs connected to maximize brightness. Well, that one's a little bit trickier, okay? But if you think about it, there's this configuration that would satisfy the 3 criteria that we've hit so far. And then there's another one that would do the same thing, right? And this is actually the other variation of this problem. Let me draw it real quick here. So with these 3 light bulbs, you open that switch, they go out. You close that switch, they're on. And they are all of equal brightness because they're all receiving the same current because they're in series, and they're identical resistances, okay? However, in this case, the 3 light bulbs have to share the voltage of the battery. Since they're all equal resistance, they would each get 1/3 of the whole voltage of the battery dropped across each. And up here, however, okay, these light bulbs would have the whole voltage of the battery dropped across them because they're all in parallel with the battery. And that means that we have maximized brightness if we do this configuration. For the other variation of this problem, which maybe you got, this one, okay, minimizes brightness, okay? Now there's other things you could do. If you had more components, you could put resistors in here and like further restrict the amount of current going through the circuit or something like that to further dim the bulbs. But just in terms of wire and switches and light bulbs that always have to be lit when the switch is closed, that does a pretty good job. And maybe some of you were innovators and figured out a better solution, but that's the one I was thinking of, and I think it's pretty good. So that brings us to the end of the free response. When I come back, I'll be presenting on some of the multiple choice stuff. See you then.